Hello everyone, my name is Jasmeet Singh. I'm part of MBA program. Today I'm going to explain my AI programming assignment. So the assignment is divided into two parts, Avalon dataset and the other one AutoMPG dataset. So I'm gonna go step by step. So first I'm gonna go through the Avalon dataset. So here in the first cell I have imported all the required libraries. Like I'm using the import warning imports to hide the warning messages for a cleaner output, and then the urlib request that is used to fetch dataset directly from URL, and then the numpy for numerical operation and arrays, and then the pandas library for structured data handling, and then I'm using matplotlib for plotting training and validation curves, TensorFlow backend, and the Keras API for building neural networks, and the sklearn model selection used to split the dataset into training and validation sets. So let's start. So here I've loaded the dataset directly from the URL and stored. So first what happens is this line, it's going to open the connection to the URL and then read the dataset and then store it. And after that I have created these empty list for features and target labels, and then I have used this loop to loop through each row in dataset. So this line explains that I am converting the bytes to string and then removing white space and then splitting by comma. So first column is for the labels MFI, and here I'm converting the remaining columns to float values, and after that I am using this to add numeric features to feature list, and then I'm converting the Python list to the NumPy array, and then here I'm mapping the categorical labels to integers, and after that I'm converting each label into its numeric form, and here I have used Keras utils to convert numerical labels into one hot encoded format, 3 classes, and here I'm initializing the scaling object, and then using that scaling object I am computing the mean and standard deviation, scaling all features, and here I'm splitting the data into 50% training and 50% validation, and the random state is 42, that is ensuring the reproducibility. And here in this cell I'm using Keras model sequential to create the neural network. So the first hidden layer has 512 neurons using the activation ReLU, input size, number of features, and then the second layer also use 512 neurons, the third layer uses 256 neurons, and then after that this output layer only uses 3 neurons for 3 classes, and the activation type is softmax, which outputs to probabilities. Then I'm using the same model to compile for defining optimizer, defining the loss function, defining the metrics, and after that I have trained the model, storing the training history in the history B variable, and in this cell I have used the plot function to plot the graph. So in this plot we see 4 curves: training loss, validation loss, training accuracy, validation accuracy. The training loss continuously decreases over 100 epochs, which means the model keeps the fitting the training data better. However, the validation loss starts increasing after approximately 30 to 40 epochs. This divergence indicates overfitting. The model is memorizing training data but losing its ability to generalize. At the same time, training accuracy increases steadily, while validation accuracy remains flat and slightly decreases. The growing gap between training and validation curves confirms overfitting. And after that, so here I have improved the model, adding the L2 penalty to reduce the overfitting and the batch normalization to normalize layer outputs to stabilize training, and then the dropout is set to 0.3, which randomly disables 30% neurons during the training to prevent overfitting. The LR schedule, which gradually decreases learning rate over time. And then I have plotted the improved graph here, and we can see in the improved model plot that the training and validation curves are much closer together. The validation loss decreases initially and then stabilizes instead of increasing dramatically. The validation accuracy remains close to training accuracy throughout training. This indicates that the model is generalizing better and not memorizing the training data. The addition of dropout, LT regularization, and the batch normalization reduced model variance. And after that, it's again I'm showing the mm, neural network shape and input. So let's move to the second slide. I mean the second code. So here I also initialize the imports initially, and then read the dataset into pandas data frame, removed unnecessary columns, removed the unnecessary columns like the name origin, and then again converted the horsepower to numeric to avoid the invalid values error. Like it's initially giving me the string error, that's why I have used that to numeric, and also I have used this to skip that error, not to skip, just to resolve that error. And according to the requirements, I have filled it with the mean value, horsepower, missing values, and then added 1900 to the year column, then split the data into 50% training and 50% validation. After that, like I have used the, again I have initialized the scalar object and use that to compute scaling parameters from the training data only, and applied scaling to training data and the validation data. Then I have built the model. Here I used the ChatGPT because I got confused which layer size is good for this. So after deciding that, ChatGPT suggested me this layer 32 and 1, and here I have again defined the optimizer and loss, and after that I have trained the model again, not again, I mean first time. 100 epochs was set to train this model. I have used a previous semester thing here just to predict the MPG values based on validation dataset and compare it with actual MPG, just an extra thing that I learned in my last semester. But according to the requirements of the assignment, here I have initialized the new vehicles, and then based on those new vehicles I have predicted the values. And the predicted values here, I can say For the required 10 vehicles, some predictions are realistic, such as the 19.57 and the 23.29 mpg. However, some predictions are extremely high, such as the 100 mpg and the 88 mpg. These unrealistic values occur because some vehicles have extreme feature values outside the historical training range, such as very large engine displacement or future years like the 2025. Neural network interpolates well within training data but may produce unstable results when extrapolating beyond it. This demonstrates the limitation of purely data-driven models. Here I have printed the values that I initially got, but every time I run it, I know it changes, keeps on changing. Here is the justification. So thank you.